Okay, so the RENKU project is a web platform and tools for reproducible and collaborative data analysis projects. I began at SDSC, the Swiss Data Science Center, in August, just like Sienna just announced. And I'm going to talk to you about this project, but first I will say a few words about myself besides where my background. So I am not an R developer. I'm mostly a Python developer with a brief foray into Fortran, but I have been really excited by the R community, and in the RENKU project, we support many different kinds of platforms and programming languages. So, and R is one of them, and I will tell you about how it integrates with our platform. And I've also been super interested in how R's plotting libraries, and so that's really, oops. Okay, so the Swiss Data Science Center, just a few words. It's a multinational team of professionals. It's federally funded, and it's half an EPFL, half an ETH Zurich. We're pretty new, but growing really quickly, and the idea is to accelerate the adoption of data science in academia and industry. And one of the ways to help do that is to provide tools that support data science and data analysis and reproducibility. So you can imagine maybe you're in a situation where you give a talk or something like this, and you share some code, and someone responds to you later. They say, "Oh, I cloned your repo, but I can't run your code. Can you help me?" And so you could imagine not just from a talk, but maybe like you have academic collaborators, business partners, decision makers, and also your future self, because you always kind of change over time, and you forget what you wrote, and the environment changes, and everything changes. So how can you fix this? So what's missing? Like maybe you're confused. Like, I use Git, I clone, and this person was able to clone the repo. So you were using version control, but clearly that's not enough for being able to computationally reproduce some kind of code that you have. So what else is missing? Did you provide the data? So providing the data that you run with the code is also kind of important, because maybe there's some specific kind of format it's in, or some specific fields that should be present. Then did you provide the execution environment? So in addition to the data and the code, the environment that it was run in is really determines whether or not you can run it at all. So that involves software dependency libraries, but it goes down to the OS. So maybe you developed on a Mac and someone wants to run on Windows or something like this. And the third part of being able to run the code, besides having the data, the code versioned, and the execution environment, is whether or not you know which inputs and code and outputs are all related in the workflow. So maybe you share some data with someone and they want to know how you generated the output, maybe to verify your results. And if you don't have the workflow captured somehow, it's difficult to see that even in a repo with a container. So, okay, maybe you're convinced you need to do something about this. And there's so many different tools for supporting all of these four steps for making a reproducible project. And you'd rather spend your time developing your code and developing your research and collaborating all these things, and you don't maybe want or even need to spend the time going through all of these options. These were gathered by the place cited at the bottom. But what we have for RENKU is, like, maybe you can just pick the best practices ones. So there are some specific tools that are known by the data science communities, by programming communities: GitLab, Jupyter, R, Docker, Kubernetes, MATLAB. And if you put these all together, you get RENKU. And so what we provide with RENKU Lab is a glue that holds together the functionality for capturing your code together with template files that help you keep the environment versioned with your repo, with also some storage for if you have any large data. And you can also launch environments like JupyterLab or RStudio or MATLAB or whatever you put in your Docker file, basically, to develop your code and then push it back to GitLab and find it available on RENKU. And if that, one quick thing is you can visit this survey at the end of this talk, or if you try out RENKU sometime, to sort of make sure that our features are matching what the requirements are from the community. So we really highly welcome feedback. And now I'll do a quick demo. And just to give you the steps that I'm going to go through before we enter the demo, the ways to interact with the way that we're going to go through this is we're going to start an RStudio session via the Environments tab on RENKU Lab. We're going to fork the project. So we're going to be able to use the project for ourselves. We're going to change something, and then we're going to commit stuff. And let's just do it. So here we have a project. So I mentioned I'm not primarily an R developer. So the tidyverse, I understand, is a good collection of libraries that you might want to use. And here we have the project, and what comes with the project are some template files. In the Docker file, we have a default for launching an R environment, as well as some extra you can add, so these are added extra dependencies for some extra a library that you would install here. So here we have ggplot2, which we just heard a lot about in the last talk. And if we want to fork this project, if we want to run an environment, we can fork the project. I've done this already because when you fork it, it builds your environment for you, which takes a little bit of time. So here we have the project forked from the original user. And now I can run an environment, which is in RStudio with some small number of resources from the latest commit. And this will take a few seconds to start, a few more seconds to start. So what's happening right now is the Jupyter Hub backend is spawning the environment, and it uses Kubernetes in the backend. And it shouldn't take that long. So now we connect. Jupyter starts, and then now RStudio will start. And here we have our environment with the templates. So this had our installed packages. We can make sure that it was installed. ggplot2. Cool. We can add our own code in if we wanted. Bin. And we want to run it. We see some cool plots. And then if you want to make sure that you save what you've been working on, you can check that, okay, we've added some code. So let's add this. Added some plotting code because you want to be a little bit specific about what you did. And then so long as we git push, the stuff will be pushed back to GitLab. A new environment will be built. And you can also use this Git GUI that RStudio has. And if we then see on RENKU in our files, we now have our hello plot script that we just added to our environment. So that's most of the demo. And then just to finish up with the slides, there are many resources for if you're trying to use RENKU. So there's a discourse where you can ask questions. There's a Gitter where you can chat about RENKU. There's some getting started tutorials. And then if you run into any bugs or you have any feature requests, you can ask them there. And we also have some open positions. Not one of them's on the RENKU team, so I know this is an R conference, but if you're a Scala engineer, you can click this one. And if you want to work with data pipelines at EPFL you can click that one. And thank you very much. So just to also add, so RENKU is under very active development. This means that if you run into any issues, we're quickly on it to get stuff fixed so that you can continue to develop your projects. And there's many more features that I didn't cover here in this time, but the main thing I wanted to point out was that you can do our development by keeping your container manageable the feature I didn't talk about was how workflows are kept together and how data sets are kept together, but these are both features that RENKU comes with as well. Thank you.
Thank you, Emma. I think we have one question, and then we have some time. I can also ask one. Daniel asks, are there any data provenances or data lineage utilities available in RENKU? Very good, you kept the timer. Yeah, maybe you see the question yourself. You can also.
Let me. Oops.
Are there? Yeah.
Oops,
down at the Q&A.
Oh yeah, are there any data provenance or data lineage utilities available in RENKU? Yes. So if you want to keep track of data provenance and data lineage, we have a command line interface that's in addition to the RENKU platform that I just showed you, and it's pre-installed into the environment. So how we keep track of data provenance, we have a dataset command where you can annotate your data with extra information besides the information that you add it, that it comes with naturally, which are like the date, time, and things like this. And then, oops, the question disappeared.
Oh yes, sorry, I answered it live. I'm sorry. I dismissed it, but it's among the answers.
I see it.
Yeah.
Yeah, and then for data lineage, we have a way of wrapping any of your script executions with a RENKU command called RENKU run, which then stores in a hidden directory a bunch of metadata about the lineage, which we then visualize on the site. So for instance, I had a slide that was sort of an illustration of what we have. So on this slide, this is one of the lineages that gets generated from the data that gets passed through these executed steps. Did that answer the question?
This person cannot answer, but it has to, because now we are out of time.
Great.
But I suggest I also have a bunch of questions, and I think the question is also like, this seems like to be really good practice to use this also in science in general and in research in general. And I think the question is also like, what do you need to know like in order to use this? So we can discuss this in room B during the break. But now, thank you so much, Emma.